गाइस आज हम लोग आए हैं चिल्ड्रन स्पेस सेंटर। यहाँ पे हमारी जैनब, हाई कर दो जैनब। जैनब यहाँ पे देखेगी स्पेस का शो, तो अभी थोड़ी देर में चालू होगा स्पेस का शो। ये जो आप देख रहे हो गोल, ये एक्चुअली गोल नहीं है, ये स्क्रीन है। थोड़ी देर के बाद जैसे ही लाइट्स ऑफ होंगे इसके ऊपर पूरा स्पेस दिखाई देगा। हम आपको स्पेस का भी व्यू दिखाएंगे।
Beyond the moon, beyond the sun and stars, far beyond the Milky Way, we enter a realm of perpetual darkness, the cold, black emptiness of space. Yet, even here, small amounts of matter can be found. A variety of different atoms and molecules spread thinly throughout the void. Together, these microscopic particles form the raw material of the evolving cosmos, the basic building blocks of the universe itself. From our present position, the architecture of the universe can be seen on a much grander scale. Here, we see the galaxies, glowing pinwheels of gas, dust, and stars. The universe is organized into galaxies of many shapes and sizes. Before us now is an enormous spiral galaxy, a typical galaxy. It glows with the light of billions of suns. Along the expanse of its arms, swarms of gas and dust are swept into vast clouds called nebulae. In some regions, a nebula may glow with an eerie light produced by the energy of nearby stars, while elsewhere, the clouds are so thick that nearly all starlight is blocked out. Thousands of these gaseous clouds are scattered throughout the galaxy. Within their frozen interiors, atoms combine into more complex molecules: ammonia, methane, carbon monoxide, and surprisingly, water. These interstellar clouds hold other secrets too. They are the birthplace of stars. About 5 billion years ago, a new, rather average yellow star condensed from a great cloud of gas and dust. Also born was a family of planets, moons, asteroids, and comets, all built with chemicals from the original cloud. The inner planets orbit swiftly. The outer planets can take decades to complete a single revolution of their far-off parent star. We now direct our approach towards the heart of this young solar system. until blue skies and liquid, watery oceans looms into view. Here, water molecules inherited from the ancient nebula collect and flow on the surface of a small, fragile, rocky world. Here we find our oasis in space. The Earth is dominated by water in all its forms. Some floats in the atmosphere in clouds of water vapor. Some is tied up in ice caps at the poles, growing and shrinking with the seasons. But most of the water ebbs and flows in the oceans, lakes and rivers that cover 3/4 of our planet. The young, evolving Earth was very different than it is today. The Earth was a barren wasteland, bombarded by comets and meteors. Volcanoes dominated the landscape, venting enormous amounts of gases. Gravity held the gases, creating an atmosphere. Eventually, the rains came, filling the ocean basins. And it was in the oceans that life began. Over the millennia, we have learned how to explore our water world. But the tools of exploration have changed. And today, our eyes look outward to space, to the other planets of our solar system. Are there other water worlds like our own? Could life, human or otherwise, survive on any of them? As we move away from Earth, the Moon, our closest celestial neighbor, is our first stop. Far from the ocean-covered world early observers imagined it to be, the Moon suffers from a simple lack of size. Too small to retain an atmosphere, any gases it once had have long since escaped into space. With no air, there can be no clouds, no rain, no oceans, no weather to erase the impact craters that scar this dead landscape. Vast ancient lava flows cover the regions that were once hopefully named seas. Yet we have found small amounts of frozen water on the Moon, mostly inside craters at the Moon's poles. Spacecraft revealed another angry, barren desert when they flew past Mercury, the planet closest to the Sun. Only slightly larger than the Moon, Mercury too is an airless, waterless, heavily cratered world. Scorched by its proximity to the Sun, the daytime side of Mercury roasts at hundreds of degrees, then plunges to well below zero as it slowly rotates into night. Still, water actually exists on this world of extremes, in the form of tiny patches of ice, clinging to the inside of craters of the north and south poles of the planet, forever sheltered from the sun. One of the biggest triumphs of the space age has been the exploration of Venus. Of all the worlds, Venus is most like the Earth in size, mass, composition, and distance from the Sun. Yet what a different world it is. Pierced by a handful of small probes, explored by radar, the thick clouds of Venus, so different from the water-bearing clouds of Earth, permanently shroud an awful reality. Clouds rain drops of sulfuric acid, not water, onto the landscape. The clouds pass some sunlight, warming the ground, but the thick carbon dioxide atmosphere prevents most of the heat from escaping back into space. This greenhouse effect traps the energy, making Venus the hottest planet in the solar system. Still mockingly known by the name of the goddess of beauty, Venus offers us a nightmare vision of planetary evolution gone astray. Larger than Mercury, but only half the diameter of Venus or Earth, Mars has enough gravity to retain a thin atmosphere of unbreathable carbon dioxide. Iron oxide, commonly known as rust, covers the surface of the red planet. In Martian summer, huge dust storms scour the surface with hurricane-force winds, while in winter, frozen carbon dioxide frosts the landscape. On Mars, we see signs of giant volcanoes, canyons, and riverbeds. But the volcanoes are dormant, and the riverbeds dry. Water once flowed here, carving the land. New evidence suggests there might still be liquid water and possibly life under the Martian surface.
मार्स पे लाइफ है। What is this?
On the border between the inner and outer planets lies the asteroid belt. The asteroids are little more than jagged cinders, small chunks of rock and iron, with very small amounts of frozen water. Beyond the asteroid belt, we enter the realm of the giant planets. As a group, they contain most of the total mass of the planets in our solar system, and most have large numbers of moons. Jupiter, the largest planet, is a typical gas giant, a huge sphere of hydrogen, helium, methane and ammonia. At some depth, the pressure probably compresses the gases into a liquid, forming a bizarre ocean of toxic chemicals. Floating in the turbulent atmosphere is Jupiter's most distinctive feature, the Great Red Spot, a huge, rapidly spinning storm system. More than 3 times larger than our entire planet, it has been observed ever since the invention of the telescope. Inside the spot, spacecraft revealed winds that reach and surpass the most violent typhoon known on Earth. But this storm rages without pounding surf and torrential rains, for water is not the raw material of Jupiter's weather. Like many of the gas giant outer planets, Jupiter is circled by a diverse family of moons, and the 4 largest are worlds in their own right. Europa has a white, smooth surface, crisscrossed by dark stripes, with few craters. The lack of craters could mean that the surface is fluid and self-repairing, most likely a cracked, icy crust over an ocean of liquid water or slushy ice. Life can be found in some very inhospitable places on Earth. Could there be life in the European Ocean? Some scientists think it's possible. New space probes launched over the next few decades may provide the answer. Our search for water takes us onto Saturn, the jewel of the outer solar system. Almost twice as far from the Sun as Jupiter, Saturn is encircled by a complex system of satellites and rings. The rings are probably remnants of a shattered moon, or perhaps the raw material of a moon that never came to be. Saturn's rings, too, are mostly ice. Though they look uniform and solid from a distance, close up, the rings resolve into a vast swarm of icy particles, each particle an individual satellite. Across ever-widening gulfs of distance, we next encounter Uranus and Neptune, only discovered in the last 200 years. Both Uranus and Neptune have a bluish color that suggests oceans. And Neptune was even named for the ancient god of the sea. But appearances are deceiving, for their color is caused by methane clouds in their frigid atmospheres. Within the clouds, charged particles circulate in a sea of liquid water, producing electric currents and magnetic fields which surround these planets. So, there may be oceans of a sort on Uranus and Neptune, but under these conditions, they probably resemble battery acid more than water. Finally, we come to Pluto, dimly lit by the distant sun. Pluto, its moon Charon, and Neptune's moon Triton may be large examples of a newly discovered class of objects orbiting in the far reaches of the solar system. They appear to be leftovers from the creation of the planets, frozen water and gases similar to the nuclei of comets. Some of the comets we see from Earth probably originated here, but most will remain, like Pluto, a reservoir of water, frozen by the cold of space into ice as hard as the hardest rock. Our star dwindles in the distance, circled by a family of planets and moons. Water exists on many of these worlds, but only on Earth did it become the major component of evolving life. With its moderate conditions, its vast oceans, and oxygen-rich atmosphere, Earth is unique in the solar system. But the Sun is just an average star, small, stable, like billions of other stars in the Milky Way galaxy. And our galaxy itself is typical of billions of galaxies in the known universe, each in turn home to untold billions of stars. Stars and planets form from clouds of gas and dust, clouds which contain water. Several other solar systems have already been discovered. How many more are out there? How many other water planets orbit just the right distance from their own average stars? Across the reaches of space and time, our quest continues. The search for life goes on. We listen for a faint echo from some far-off civilization, for a signal from an alien world, for signs of another oasis in space.